Assalamualaikum warahmatullahi wabarakatuh. And having a good day, everyone. My name is Muhammad Khairul Ikhwan bin Azmi. I am from class AS121B. And my presentation is about corn ethanol. What is the corn ethanol? Can corn ethanol we can drink or we use? In abstract, firstly, current bioethanol production entails the enzymatic depolymerization of cellulose, but this process shows low efficiency and poor economy. Second, the high yield of cellulose is extracted from corn stalk using a green solvent 80 watt percent 1,4-butan media without destroying the structure of the lignin. The first hydrothermal hydrogenolysis step uses a nickel WOS sulfur dioxide catalyst to convert the high cumulative concentration of cellulose 30 watt percent into a polyol mixture with a 56.5 Celsius per carbon percent yield of ethylene glycol. There are 6 methods in making corn ethanol. Now we go to the introduction. Bioethanol is a promising green and renewable liquid fuel that is used as a gasoline additive. Ethanol we can call ethyl alcohol, grain alcohol, or alcohol. Its molecule formula is C2H5OH. The sequential hydrolysis and fermentation of grain involved in first generation bioethanol production. However, this biofermentation process shows low activity and low economy, such as 1 mole sugar produces 2 mole carbon dioxide and 2 mole ethanol. Therefore, the development of advanced catalytic approaches for the conversion of high concentration of cellulose is highly desired. The concentration of cellulose that can be converted and the amount of bioethanol that can be produced along with the duration efficiency are crucial parameters in the cellulose bioethanol since they determine the overall economy of the process. Now, we go to define the methodology. First process is milling. Whole corn kernel are ground into a form of flour or meal. The meal is mainly starch. The starch is carbohydrate made up of a long chain of sugar molecules. Number 2, liquefaction. In the liquefaction, add water and cool. Water is added to the meal to make slurry. The slurry is heated to break the long starch molecule into smaller pieces. The enzyme alpha amylase is added to catalyze or speed up the breakdown of the starch molecule. Now, the process number 3, saccharification. Starch molecule pieces are broken down into simple sugar glucose. This reaction is catalyzed by an enzyme called glucoamylase. Number 4, process fermentation. Single-cell microorganisms called yeast are added to the slurry. Fermentation in the biochemical process that occurs when yeast break down glucose. Yeast get energy from glucose. As a result, ethanol is produced. And after the fermentation process, we go to the distillation process. Distillation is only have two process: evaporate and condense. After distillation is denaturation. Denaturation is about a small amount of gasoline is added to full ethanol to make it indecreable. Now we go to detail this process. In milling process, in dry milling, the entire container or other starchy grain is first ground into flour, which is referred to in the industry as mill, and processed without separating out the various component parts of the grain. Number two, the mash is processed in a high temperature cooker to reduce bacteria level ahead of fermentation. And number three, the anhydrous ethanol is then blended with about 5% denaturants, such as natural gasoline, to render it indecreable and thus not subject to previous alcohol test. It is then ready for shipment to gasoline terminal or retailers. It is show our milling process. Liquefaction process is the process of dispersion of the highly viscous gelatinized starch granule and the partial enzymatic hydrolysis. Number two, partial hydrolysis by this enzyme not only reduces viscosity but also prevents starch retrogression upon a further cooling. Number three, thinning of the viscous starch suspension by chemical means using acids such as hydrochloric acid or oxalic acid at high temperature of 140 to 150 Celsius and extremely low pH, pH 2.0, was common practice prior to the introduction of this thermostable enzyme. Now, saccharification process. Saccharification process is a major constraint for bioethanol production due to high cost of enzyme production and complications associated with the removal of her acid, alkali, and sulfate after neutralization. This combination with diulic acid to enhance biomass hydrolysis. Crude enzymes can increase the yield of hydrolyzed macroalgal biomass for bioethanol production. And this fermentation process. Ethanol C2H5OH is a light alcohol and is a volatile, colorless, and flammable liquid with a characteristic odor. It is also known as ethyl alcohol and often abbreviated as ethanol. The most common way of production is the fermentation of sugar or starch from agricultural caused by yeast or bacteria. Single-cell microorganisms called yeast are added to the slurry. Fermentation is the biochemical process that occurs when yeast break down the glucose. Yeast get energy from glucose. And fifth process is about distillation and dehydration. The product of fermentation process is only 10 to 15% ethanol. It must be concentrated to become pure 100% ethanol. Ethanol has a lower boiling point than water. It is selectively evaporated and condensed in a process called distillation. This process produces ethanol that is 95% pure. The remaining 5% of the mixture is water. The mixture is strained and the hydrogen produces pure ethanol. Next, after that, denaturation process. A small amount of gasoline is added to full ethanol to make it indecreable. It is how the denaturation process. Now we go to the conclusion. The bioethanol production from corn. The full ethanol industry in the United States has expanded rapidly over the last decade and currently uses more than 40% of the total corn produce. Modified processes are getting implemented in response to low crude oil prices and overproduction of dry distillate, bring with soluble the major core product in the process. Currently, only a few plants are using front-end fractionation technology due to cost or retrofit fermentation issue or core product quality. As technology matures, use of transgenic corn hybrid and engineered yeast strain reduce the enzyme in the corn ethanol process and improve ethanol yield. Technology improvement, especially in treatment and hydrolysis, are required to make the process commercially feasible. Now we go to discussion about corn ethanol. What is the effect of ethanol consumption on the petroleum industry? We all vehicles on Earth use ethanol as fuel. Can the use of ethanol fuel reduce the concentration of carbon dioxide gas on Earth? What are the advantages and disadvantages of using corn ethanol? Now, recommendation in the that will not have an impact in the majority because the use of petroleum is more widespread than the use of corn ethanol. Number two, not all vehicles need to corn ethanol. Most vehicles on Earth still use petroleum, and this lifespan of petroleum fuel is longer than corn ethanol. Number three, corn ethanol can reduce the concentration of carbon dioxide gas in the Earth. It's because the percentage of corn ethanol is lower than petroleum. It is advantages and disadvantages of using corn ethanol. Advantages: number one is it is proven to reduce combustion emission. Ethanol is able to reduce GHG emission very effectively because 3/4 of ethanol that is free in the environment can be broken down in as little as 5 days. Number two, it is a fuel that is energy balanced. A new form of ethanol called cellulose ethanol is more effective. Disadvantages: number one, it is not as effective as fuel as traditional gasoline. But fuel vehicle that can run on if you have found that their gas mileage rate are over 25% lower. In some models seeing a 30% reduction with city mile. Number two, it is costly. Prior to 2012, the balance report that ethanol produced in the United States received a subsidy of 45 cents for every gallon of fuel that was produced. Now, this is how my reference. That's all. Thank you.